So we have encountered classes and we have encountered structs, and so we saw one of them used to create views in UIKit, and then the other in SwiftUI. So classes in UIKit, structs in SwiftUI, and let's see what's up with those. So let's create another playground. And let's play around with these a little bit. So if I have a box and I want to be able to put something in, so this is a magic box. Let's create a magic box. If I put something inside, it should double whatever I put inside. So let's think about what we need to be able to do here. So let's create a box. So yeah, we want a box, and then we want to be able to, maybe when we're shaking the box, we want to be able to double whatever's inside. So we'll have our container will be called box, and then we'll have a function on there, shake, and then I want to be able to look inside the box and see what the value is. So we want to be able to put something inside, so we'll have some sort of a value that holds our box. So let's choose a class for this. So we have a box class. Our value, let's use doubles for now. So a number with decimal places. And then, so here we have a shake function. And then this will do something, and then we should be able to hopefully double whatever we put inside. All right, so we have a compile time error, and this is one of the I think great things about Swift. So we are not allowed to declare a type. So in this case, we are not allowed to build a class that allows us to be in a state where something is undefined. So if you're thinking about instantiating this box right now, so maybe we have a variable and we're instantiating box. What could be a programming mistake that we do here? That something that we might be doing in another language. So what could be undefined right now, or what actually is undefined right now? So you're onto the solution. So that is what we're gonna do. What is undefined right now? If I'm creating a box like this, if we're looking at our box definition, what is undefined when we're instantiating this box? Value. So we didn't say what the value is in this box. We're going to see different kinds of. So one thing that you might think is, but what if we want the box to be able to start off with nothing in it? We can do that, but we'll cover that next week. So how would we do that? We would say, hey, this value could be nothing, or it could be a double. I'll just show you real quick how we would do that. We add the question mark here, and now the value could hold a double or nothing. But we're going to talk about next week how this works, what we're doing there. So for now, our value has to exist. So when we're creating a box, it has to have something in it. So right now, there's no guarantee that value will hold, that there will be something assigned to value. So the compiler tells us, right now, you could be in a state where maybe someone forgets to assign a value, and then we're in trouble because we're expecting there to be a value. We're saying, hey, value should be a double. So one of the rules in Swift is every property has to be initialized somehow. There's a couple of ways we can do that. And one of the ways that we can initialize properties is, like you said, with a constructor. So we can actually click again on the red here. So the compile time error we had was class box has no initializers. So let's, what it's telling us is there's a property that is undefined when we are creating it. So let's fix it. And what the compiler decided to do is assign a default value. So that's one way to initialize things. We can declare the property and then initialize it in line. So that's one way that we can do it. What's another way? We can create a constructor. Constructors in Swift are called initializers. So I think constructors was used in Java. Here they're called initializers. Same thing. And then it's already auto-completing it for me here. I can hit tab. And we now have an initializer that takes a value, and then it assigns the value to our property that we've declared. Okay, so we now fulfilled the requirement that every property has to be initialized somehow. And we saw two ways to initialize a property, with a default value and with an initializer. So now we have another compile time error. So why do we have this compile time error? We're trying to create a box without passing in an initial value. So the compiler again is warning us, saying, "Hey, we need to have that value parameter, and now we can pass a value in." If we do want to be able to instantiate a box without any parameters, we can enable us to do that. So we could create another initializer that takes no parameters, but now we still have to instantiate all of our values. So now we have to come up with a default value. So we could do the 0 initialization. So this is actually the same. So this is the same as if we had done this, but so there's another interesting thing happening here. So even though we have all properties initialized, we have another compile time error here now. So it's telling us we now need to provide a value, because we have an initializer that that requires a value. We have to use if there's one initializer, we have to use an initializer to instantiate it. If this initializer wasn't there, we could instantiate a box because we have this value initialized in line. So the rules are all properties have to be initialized at all times. We can't have something not initialized. We'll see later, we can initialize something with nothing, but we have to be explicit about that. We have to state, hey, there's nothing in this box, or there's nothing in this variable. So we have to be explicit. Everything has to be initialized, even if it's to nothing. We can initialize variables. We can initialize properties in line like this. But the second we provide our own initializer, we have to call an initializer now. So we have to provide an initializer. So if we want this value initialized in line, we can do it like this. So now we have both ways of creating a box. So now box has 0 in it, because we're using this initializer, or we could pass in a value and initialize it this way. Any questions here? Cool. Okay, so we have a box. So yeah, we have a value, we have an initializer, and we can shake the box. So I said this was a magic box. When we're shaking it, the value would double. So let's double the value. If we're passing in 0, obviously we won't be doing anything with that. Let's say, let's pass 2 in and shake the box. And then let's see what is in that box. So here we'll bring the gutter a little bit closer so we can see it. so yeah, we have our box. We're creating a box. We're shaking it, and then now our value is 2. So the contents of our box changed when we hit the shake method here. Did we create a new box instance? No, we still have the same box instance here. So we don't actually have to have this be a variable. So once box is assigned, we're not changing the instance. So we're creating one box, then we're shaking it, and then we're probing its value. So we're not actually changing the box itself. So the box could be a constant. So the box doesn't change. We're changing the contents of the box. Any questions here? All right. So let's create another box. So we'll create another box, and this time it'll be we'll create a box out of a struct. We'll call it maybe struct box. And we do the same thing. We have a value, and we'll have a shake function. Okay, and so structs have a cool behavior that classes don't have. So classes have been around since Objective-C. Structs are a new thing in Swift. And classes are interoperable with Objective-C, so they go way back. Structs are not. So structs are a new thing. So with the new thing that we get to play with, we get some fancy new tools. If I were to create a struct box, here let's do a constant again. I get, but by default, I get an initializer that initializes all my properties. So let's provide 2 again here. So with classes, we get one free initializer if there aren't any. If all of our parameters are initialized in line, we get the no parameter initializer for free. For structs, if we have parameters, we get an initializer for free that initializes all of the parameters. So if I'm adding another parameter here, maybe color. We're in UIKit. Let's do. There we go. So I'm adding another parameter. So we'll get a compile time error here in a second because we're not initializing all of our properties. Again, for structs, all properties have to be initialized. So we're getting a missing parameter error. So we're declaring properties. Because we're in a struct, we get an initializer for free that initializes all of those properties. There's one downside to not creating your own initializers, and that is if I were to reorder the parameters, we now have a compile time error because the labels are flipped. So that's not ideal in my opinion. There's one other reason why you might want to create initializers for structs, and that is, let's say we'll talk about sharing your code with other developers later. So we're going to use a package manager where we can use other people's code. We can package up our code and have other people use it. If our box is so amazing that we want other people to use it, we might want to make it available outside of our environment here, and we would then say this box should be public. So if the box is public, accessible outside of for other people to use outside of our package that we're creating, then so the default initializer, because it doesn't have the public keyword in front of it, is private still, or it's internal. It's internal to the package. So no one would be able to instantiate your box, which is annoying. So it would make sense to just provide this initializer. Now you can make the initializer public, and people can use your box. So for a couple of reasons. One, because the parameter order matters, and because sometimes it can be annoying to package something up and then you later have to come back to add the initializer. I think it makes sense to just, it auto-completes, so if you start typing in it, Xcode will just create this constructor for you, or this initializer. So I think it makes sense to provide this most of the time. Anyways, so we have our struct box. So now let's do the same thing. So we want to be able to shake it, and actually we don't need the color, so let's get rid of that. So I want to be able to shake the box, and then what should happen when I shake the box? We want to multiply, we want to double the value, and we have a compile time error. So this one should look similar, or should look familiar. We saw the exact same compile time error last week. So what does it say? Cannot assign to property self is immutable. Where did we see this? Does anyone remember? Very good. So let's go back there. So we have our Swift UI demo. Okay, so we had our button. So again, I can build this right now, and we have that that we'll get our app where we can press the button and it toggles the visibility of our label. How does it toggle? It modifies this property. This property is inside a struct. So if I remove state, we end up in a situation where, so I can't build to the app anymore. I can't click here. We have the build failed. We have a compile time error. Here, let's get rid of the canvas here. So we have a compile time error. Cannot assign property self is immutable. Same thing. So we have a property on our content view, and we're trying to manipulate this property, but we're saying that our content view is a struct. So we're running into an issue here. So we have the same problem. When we're shaking the box, we can't double our value. So this might seem annoying, counterintuitive. I want to be able to shake this box, and I want it to double its value. But this concept is actually pretty. We are encountering this in a lot of real-world scenarios. So let's rename this box maybe die. For like a die, multiple dice. So we're creating a dice set. If you're shaking your die, you wouldn't expect the numbers to change on your die, right? So if you're shaking if you're holding the die in your hand and you're shaking it, those numbers better stay the same, right? Otherwise, you have a really funny die. So in that sense, the die is immutable. So you have this object that has properties on it, and we can't change them. So how do we interact with a die? So the die would maybe not just have one value, but maybe it has values, and maybe they're let's do a coin. Let's do a coin. So we have heads, and maybe it has a head of a person. Maybe Oh, here we go. Maybe it's a cat. Maybe there's a cat on there. And then maybe we have tails, and then that is often some sort of a value. Maybe this one is 10 cents. So, I don't want string, I want integer. Okay, so if we have a coin, so this coin has a head side, it has a tail side, and I'm not expecting, if I'm holding the coin in my hand, I'm not expecting the coin to change its properties when I'm shaking it. So how could I create a change with a coin? I could put it in a box or like a container and then shake that, and then depending on how it flips upside, which side faces up, that's how I can interact with that box. Does that make sense? Okay, so coins, we can't change the value on it. In a box, like the inside of a box might change the value. So maybe instead of so maybe let's build a box here real quick that can hold a coin, and maybe it can hold a coin and a double. So how might we do that? If we want a box that can hold anything, not just a double, but also maybe a coin, how would we be able to do that? So let's have our coin here, and if I want it to be able to put a 2 in that box, and I also so box with Boolean, with a double in there, and then a box with a coin, and maybe I want to put this coin in there. Well, here I guess we can instantiate a new coin here. So let coin heads, we create a cat again, tails 10 cents. So I want to be able to put either the double in there, or I want to be able to put the coin in there. So let's see what we get if we try to do that. So we get another compile time error. Cannot convert value of type coin to expected argument type double. So Swift is a strongly typed language. What does that mean? So every variable has to, so we already saw that every variable has to be defined, so we can't have something undefined. So if we're declaring a variable as a property on a class, that variable has to be assigned by the time we instantiate that class. So it has to have something assigned to it. The other thing that is not allowed is to have a variable that changes its type. So we can't have a value that holds a double at one point, and then it just holds a coin at another point. So that property of Swift Swift is strongly typed. So once we declare a type, it has to stay that type. Any questions there? So who knows a language that is not strongly typed? What language is not strongly typed? Where can you assign maybe a string to a variable, and then a little bit later you can assign an integer? Yeah. JavaScript. Yeah, very good. So yeah, vanilla JavaScript. So JavaScript without anything surrounding it is not strongly typed, because it is sometimes very nice to have a strongly typed JavaScript. You can use JavaScript with some flavors on top, and then you have, so I think TypeScript is an example of JavaScript with types. But yeah, JavaScript by itself is not strongly typed. All right, so we can't put a coin into a box that only can hold doubles. The way we could imagine that is if the box has a little slit for where a coin could fit in. Maybe we can't put a tennis ball in there. So that kind of makes sense. But we could, the concept of a box still makes sense in the context of maybe wanting to put a tennis ball in. So could we, instead of now duplicating all of our work and changing this to coin, so can we avoid having to make this? So this to me seems very redundant, like we're creating all of the code again. So how could we do it that we can put either coins in this box or doubles? And then, so we would have to stick with that. So once we decide what kind of a box it is, we would have to stick with it. So how could we do that? There's a concept called generics in Swift. So we can just make up a type here. So this is the generic type. And it's for these container types of things, it's often just element. So we're going to say, so we have the name of the class, and now we're saying, so we have these alligator brackets, these pointy brackets, and I'm declaring a name for a type that we'll be using from inside this box. And then wherever we are encountering the value that we want to be able to either be coins or doubles, we replace it with that. So, and then we can't have this initializer anymore. Any questions here? So we can create a generic box that can hold element, and then how do we, and so now actually all of our compile time errors went away. And we'll kind of unravel why this happens here in a second. So compile time errors went away, it all built. How did we do this? We created a box that can hold a generic type. So we said the type that we're going to be using will be called element from now on. Sometimes you'll see T for type. Oh. So this is a little bit discouraged to have these one letter or one character or two character type names in generics, because it's not quite clear what type of thing you're putting in there. But you'll see T a lot. You'll see element a lot. So this is not a type. This doesn't exist. If I try to create an element, I would not be able to. This does not, oh my gosh. So this does not exist. Element is not a type. I cannot instantiate element. It is just the placeholder for whatever type I'm putting inside. So, but yeah, so once I'm setting up a box to hold something generic, I can now put either coins in there, coins, or doubles, which is very nice. Any questions here? Sometimes the compiler won't be able to figure out what kind of a box you want. Then you'll see something like this. So you can say, hey, I want a box that can hold doubles. Hey, I want a box that can hold coins. Okay, or you'll see it like this. So the parameter, the constant here could have the type, or we can be very explicit as we're instantiating the box. Any questions here? Okay. Well, so what happens if we have a coin box and we're trying to assign a double box to it? So let's say we have our box with coin, and now I'm going to assign box with double. What do you guys think will happen? Cannot assign it? So there's actually two reasons why we won't be able to assign this. So why won't be able to assign it? Different type. So let's try that. So yeah, there are different types. So once we have a coin box, we can't put doubles in it. We actually have another error here. We cannot assign box with coin. It is a let constant. So here we have box with coins. We make that a variable. We now have the other compile time error. So we can't assign a box with doubles to a box with coins. All right. But yeah, so so structs, we can't change the properties on an instance and then have that instance be the same one still. We'll see a couple of we'll see ways that it will appear like we have changed a property in a second here, but we won't be quite doing that. And then so with classes, we are able to change the values inside. So any questions here? So let's bring up our SwiftUI demo again. And so here we still have this compile time error, right? Cannot assign property self is immutable. So we have a variable inside a value type. We have a struct here. And when we're pressing the button, we're trying to update the is showing label property. So why can't we update it? We are inside a value type. We can't change a property from within our content view here. So we saw that in SwiftUI, there's a special treatment that we can do to a parameter, and then we'll be able to store something. We'll be able to update that. So let's see if we bring in our box here. Let's bring our box into our content view. And so what if we said our content view has a box, the type of this box will be a box that holds booleans, and then the initial value of it will be true. Okay, and then let's change that box's name to be is showing label. So now when we're trying to assign a value to is showing label, we still won't be able to change the box itself, but we can change the contents. So if we were to say value and value, and then here, the compile time has went away. Question? Yeah, you have a question?
So is it that now instead of the showing label, that's an actual value, since it's now a class, that's a pointer?
Yes. So we could make this a constant. So we have behind the scenes, we're dealing with a reference type. So that we have some location in memory that we have this box live. So did you have another question there?
Yeah, so it's just, that's making it immutable.
Yes.
That's not changing.
Yes, that's it. Yeah. So yeah, we're not changing the actual contents of we're not changing any actual property on our content view. We kind of cheated. We said, okay, fine, I can't change my view. It's immutable. I'm gonna put this box in here, and then I can change whatever's in this box. So we kind of went around the rules. And then we can affect the change. We can change the things in the box, and therefore we're not changing the view, we're changing the things that are inside this box. Yep.
So is that a little bit like if you were to have a page and then smaller components that have their own like things going on inside of it?
Yeah.
With the page, that's still immutable, but since it's in that box, that's how it's kind of working to be its own component.
Yeah. I think you have some great intuition there. Yeah. we'll unpack a lot of what you're saying there in a little bit more detail. Yeah, very good. Very good. All right, so yeah, views are immutable in SwiftUI. To be able to change state, we have to resort to some trickery to be able to change something inside the struct. There's something else going on with the state annotation here, though. So we had this is how we had changed it before, or this is how we had solved it before. So let's see what happens. So we have our content view right now. We have this is showing label box. Let me build this and see if our app still works. Okay, so if I hit toggle, our label doesn't update. Why does it not update? If I go, if I comment this out again, I guess we'll have a compile time here in a second. If I hold down Command, I can explore a thing in Swift. So for example, if I hold down Command and I'm clicking on button, oh, I guess I can't do it while I have compile time errors. Why was that so loud? Okay, so compile time is wait. So I'm holding down Command, and my cursor turns into this hand. So if I click on button, I have an option to go to places where button has something defined. So I clicked on the initializer of the button, that's why it's giving me this, or the definition of the button. So if I click here, it takes me, so this is the place where we are. So we are in the Swift UI package, and then there's a button described here. So yeah, for the button, actually really useful already. So button has this generic label, so that we're seeing a generic type here, which is interesting. We're seeing that button is a view, and therefore must be a struct. So it's a Swift UI view, therefore must be a struct. And we also saw, so it needs to be accessible from outside of the Swift UI package, so it's public, and its initializers have to be public. Otherwise, we wouldn't be able to use it. So that was interesting. So we're seeing a couple of things that we just talked about. If I inspect, so then I have to make the compile time errors go away here real quick. So the reason why so something was funny. We clicked the button, but it wasn't updating our our view here. So if I hold down Command and I hover on state, we're unraveling a little bit more about what's going on here in Swift UI. So states are dynamic properties. So we'll talk a little bit later. So this looks like we're inheriting from dynamic property. Everyone should know what inheritance is. Is that correct? Who remembers what inheritance is? Yeah, well, hopefully everyone. So structs actually can't inherit from anything. So we have protocol conformance. So protocol is another name for interface. So we have our state adheres to the dynamic property interface. What that means is state is a special thing that when we're changing it, it'll yell to Swift UI and say, hey, there was an update here, tear down the house, we're building a new house. So anything that is a dynamic property, if it gets updated inside a Swift, inside a Swift UI view, will result in your view updating, in that house getting torn down. So we're not doing that in our box. We're not doing that here. Does that make sense? Okay, so we got mostly there. We're able to change something inside of our view, but Swift UI won't update right now because we're not a dynamic property. a little bit later, we will be able to build something ourselves that will also be able to trigger an update in SwiftUI. And so we won't see this for many, many weeks, but the thing that allows us to do that, or the thing that we are doing here with the state, we're wrapping this property. So we have a property wrapper. So we have a property wrapper state. That is a dynamic property. So property wrappers allow us to take whatever property this is, and we are wrapping it with something. So in this case, we're wrapping it with a magical box that yells at SwiftUI, hey, update the view. So that's what this state annotation here does. It's a property wrapper for our Boolean here. So we have a Boolean, property, but so Booleans are value types. Since Booleans are value types, we can't affect their, we can't update them inside of a content view. So by wrapping our isShowingLabel Boolean with this magical box that yells at SwiftUI, we can trigger updates. So there's a lot here. I'm not expecting you guys to remember all of this. The things that I hope that you guys remember is classes are value types. Inside classes, we can change the insides of it. So is that clear with everyone? So classes are value types. We can change the insides without the outside knowing about it. Structs are, so if classes are classes are reference types. We can change whatever we want in there. Structs are value types. So value types are things like booleans, integers, doubles. So we don't have a reference to memory that we're storing in our variables. We are storing the actual thing, and if it updates, we get a new object. So if we have a variable that holds the value 7, if we wanted to hold the value 8, we get rid of the 7, and we're now putting an 8 in there. If we had a class sitting there, we would just be able to update the insides. So classes are reference types. We can change the insides. Structs are value types, and they are what they are. So we get the thing that we got. If we want it to update, we have to tear it all down, get a new one. There's one thing I want to point out right now. I'll do that later. Okay. So yeah, to be able to change a value inside a content view, it has to be, or inside a view, it has to be specially wrapped in a state annotation for us to trigger an update in the view and for us to make a change here. Yes, question?
I still don't understand why it didn't trigger with the previous.
So if we had this,
Yeah, why did it trigger anything?
so our box is not special right now. Let's see.
Was it the property wrapper?
So we have a box, but it's not a special box. So the special box, and I'm being like very flippant with the definition here. So special meaning there are special kinds of things that alert to SwiftUI that it needs to redraw. There's some things that we don't know yet, but the problem we solved was we can store something inside a struct that is mutable now, so we can affect the change here. The mechanisms of how this alerts SwiftUI to redraw, we haven't covered yet, and we won't for a while.
So we.
Ju-
Not asking for like a definition.
No. Yeah. So the thing to remember is for the structs and classes, the thing to remember is 1 second. So for structs and classes, classes are reference types. We can change the insights. Structs are value types. We can't change the insights. We would have to get a new one. And then, so last week we covered that to be able to update the view, we have to have a property annotated with state. So the why we haven't covered. This is just, it now makes it special. If we change it, it will trigger the view to update. I know this is probably slightly annoying that there's like some information missing. Just know that if this state property updates, the view will update. So we have, we're reading from this property here to decide whether or not to show the text or not. So when this updates, our body gets redrawn and rebuilt. And we'll see exactly what's happening a little bit later. Any questions? Okay. So I know all of this, like what's going on behind the scenes can be a little bit dry. So I want us to build, with what we know now, we can build an app. We can build something that does something, not just hides a label and shows it again. So I want to spend the rest of the class to actually build something so that we have something useful. Also, we'll see a couple of, so we've seen the button, we've seen the text. I want us to see a couple of other views that we can use so that you guys can play around with something already. So let's do another break. Let's do another 10-minute break, and let's come back at 9:05.